In this video, we will go through physical and chemical changes. So we'll first define a physical change, so this you should be familiar with. So with a physical change, the substance remains the same substance, even though it may change state or form. So a physical change occurs when matter changes from one phase to another. So for example, when an ice cube melts, it becomes liquid water. And these were the different states of matter that were covered in a previous video here. So just remember that if an object is a solid, it can melt to become a liquid can freeze to become a solid, a liquid can evaporate to become a gas, or a gas could condense to become a liquid. A solid can sublimate to become a gas, or a gas can deposit to become a solid. So it's those changes of states when we talk about a physical change. So, water still remains water. It's just either a solid, liquid, or a gas. A chemical change now. The original substance is changed into one or more different substances that have different properties. So, for example, when zinc metal is mixed with hydrochloric acid, a chemical change occurs to produce two new substances. So you get hydrogen gas being produced and zinc chloride being produced. So a chemical change is you're making new substances. So you're taking existing substances, um, combining them together, or causing a reaction between them to create something new. So, for example, a penny placed in nitric acid would produce a compound called nitrogen dioxide. So that penny is mostly copper. And everyone's seen nitrogen dioxide. This is the kind of the browny, hazy stuff that you see in the skyline. That is a result of a byproduct of our pollution. So there are ways of knowing or signs that you can look for that indicate that a chemical change has occurred. So for example, a color change occurs. So for example, the formation of rust. So you have a nail that is silver in color and might turn this brownish red color. This change of color indicates a chemical change has occurred. Another sign that indicates that a chemical change has occurred is that energy is released or absorbed. So for example, heat is produced when a candle burns. So the candle itself burning, this light or energy being produced, that heat, is a sign that a chemical reaction is occurring. The wax that is melting around the candle indicates a change of state. So that is a physical change. The third sign that a chemical change has occurred is that gas is produced. So for example, bubbles that form when baking soda is mixed with vinegar. So that gas being produced is an indication that a reaction is occurring. The fourth sign that a chemical change has occurred is that light is produced. So for example, fireworks. So if two substances are mixed together and they start producing light, that is an indication of a chemical change. So the other example are glow sticks. Glow sticks, you have to break them and then shake them in order to produce that light. So those two chemical substances are separated by that little glass vial, which usually will contain peroxide in it. When you break that peroxide and then shake it around, that will mix with the chemical outside of the glass vial, and those two chemicals mixing together will create a new substance that will produce light. And so that is a sign of a chemical change. Now, you will also get formation, or you could get formation of a solid. When you get formation of a solid in a chemical reaction, this solid is referred to as a precipitate. So it is a solid that separates out of solution during a chemical change, and this is called a precipitate. So think about if you've ever mixed lemon juice with milk. The chunks that form are a precipitate resulting from that reaction of lemon juice with milk. Those chunks that precipitate are also called curds, and those get collected up, squished together, and then you can form something like mozzarella or cheese curds, which gets used on poutine. So those little solids that come out of the milk solution when it's mixed with that acidic lemon juice, is that precipitate. And then the last sign that you can look for that a chemical change has occurred is that the change is often difficult to reverse. This one applies to most reactions, although there are some reactions that can be reversed, which if you go on to do grade 12 chemistry, you will learn all about. But in grade 9 science for us, we say that the change is often difficult to reverse. Sometimes you might read that the change is impossible to reverse, but we'll phrase it as often difficult to reverse. So, for example, as wood burns, it turns into a pile of ashes and gases that rise into the air. After the wood is burned, it cannot be restored to its original form as a log. Or think about the fact that, if you cook an egg, that is a chemical change, a color change occurs while you're cooking an egg. You cannot uncook the egg. That one's difficult to reverse. So just always keep in mind that if you're not part of the solution, two liquids that are mixed together, then you're part of the precipitate. So the resulting solid that forms when you mix those two liquids together. Think like milk solids, milk chunks. We'll also talk about corrosion as well as a form of a chemical change. Corrosion or rusting is a slow chemical change that occurs when a metal reacts with oxygen. And this is oxygen from the air to form a new substance known as an oxide. Corrosion is an example of a chemical change. The most common example of corrosion is rusting, which occurs when iron reacts with the oxygen in the air to form iron oxide. That iron oxide doesn't have the same strength or integrity as iron, and so that iron oxide just flakes away. Every year, millions of dollars of damage is caused to buildings, structures, and vehicles due to rusting. Rust is particularly damaging because one of its physical properties, rust is porous, absorbing water. This causes the rust to flake off, leaving another layer of fresh metal to be attacked by oxygen. The process continues until the rust has eaten through all of the metal. So, because our cars are made out of steel, for example, or made out of iron, which is commonly steel. That iron can react with oxygen in the air to form that rust. So there are things that we try to do to limit the amount of rust or to slow the progression of rust. So some of the things that we can do to prevent corrosion is the use of paint. So painting the surface of the metal prevents oxygen and air from breaking down the metal. As long as the painted surface is not broken or cracked, oxygen in the air cannot get at the metal. This is one of the reasons why we paint our cars. Plating is another way of preventing corrosion. So some metals are protected with other metals that corrode easier, such as zinc. The layer of zinc protects the inner layer as it is used up slowly. So if you ever buy an item and it is galvanized, galvanized means that it has been coated or plated with zinc. Zinc, when it reacts with air, will form a compound called zinc oxide, which is just as hard as zinc, so it will protect the iron on the inside. Another way of preventing corrosion is through alloys and plastics. So alloys of steel, which is a mixture of iron, nickel, and copper, form oxides that help prevent rusting. So steel is iron, but iron mixed with other things. And then plastics do not corrode and generally maintain their strength if exposed to air. So substituting the use of iron or metal compounds with that of plastics helps reduce the incidence of corrosion as well. So that is the end of this video for physical chemical changes.